Welcome to the deep dive. Our mission today is pretty laser-focused. We're tackling a stack of sources all about the world of high-performance industrial equipment. And specifically, we are drilling down into portable ventilation solutions. You know, the tools that keep people alive and keep projects running in some of the most dangerous environments you can imagine.
Yeah, and we're not talking about like a fan you'd pick up at a hardware store. Not even close.
No.
We are looking at RamFan portable ventilators. These come from distributors like PEnergy.com, and they're all built on the global engineering standards of a company called Euramco Safety.
And the environments we're talking about here are, they're intense.
Oh, absolutely. These are places where the air itself is a hazard. We're talking confined space entry, petrochemical tank cleaning, huge utility vaults, even fire rescue staging areas.
So what jumps out immediately from the sources, especially from the perspective of, say, a safety officer or a procurement manager, is that reliability isn't just a feature.
No.
It's everything. It's the entire reason for the purchase.
It has to be.
If you're managing lethal vapors or air with no oxygen, you need a guarantee. So our mission today is to figure out not just what these things are, but how the engineering choices really make a difference.
Exactly. How they cut through the toughest challenges to keep people safe and, just as importantly, keep incredibly expensive projects on schedule.
Okay, so let's set the scene. Why is this kind of ventilation just completely non-negotiable?
Well, the source material really hammers this home. The central problem is that subpar ventilation is a catastrophic liability. It's not just about, failing an inspection.
Right. It's about downtime.
It's about massive unplanned downtime, and that has astronomical costs. Think about a major refinery shutdown.
Okay.
Those projects run on multi-million-dollar daily budgets. If the ventilation inside a tank fails, the entire site can just freeze.
And that could cost the company what?
Potentially $2 million, maybe more, per day.
$2 million a day. Wow.
In lost operational time. It's staggering.
That really puts the equipment choice in a different light.
Yeah.
You're not just buying a fan. You're buying insurance against, seven-figure delays.
You are. And the sources point out that choosing a brand like RamFan means you're instantly meeting global benchmarks. We're talking about the big ones.
OSHA, NFPA.
All of them.
Yeah.
Plus, whatever internal specs a specific plant has. It's like a compliance shield you get right out of the box.
Which has to be a huge deal for the people making the buying decisions.
Oh, it's the core of the procurement mindset that the documents talk about. Industrial buyers aren't just looking for the best price.
No, they're analyzing risk.
Exactly. Every single purchase is scrutinized because a failed piece of equipment doesn't just, inconvenience a worker. It stops the entire job. It can lead to injuries or worse, and that gets attention all the way up to the boardroom.
So the mandate is simple.
It's crystal clear. The unit has to fire up every time. No excuses.
Okay, so if reliability is the #1 priority, let's get into the engineering. The sources make it pretty clear that for the heavy-duty stuff, it's all about internal combustion engines.
For the most part, yes.
And one brand name just keeps coming up over and over again, Honda. Why them? What makes a Honda engine the default choice for this kind of unstoppable runtime?
It's really a mix of engineering history and just sheer parts availability.
Okay.
When uptime is everything, you need an engine that can just run for hours, for shifts, in high heat, covered in dust, exposed to chemical.
Now, Honda's GX series can take that.
They're built for it.
Yep.
And they're globally standardized. So whether your job site is in Texas or, somewhere in Southeast Asia, you can get it serviced. You can find the parts.
There's one model in particular they mentioned.
Yes. The common workhorse, the one we see across almost all the big gas-powered units, is the Honda GX200. It's just that perfect sweet spot of power and endurance.
So if we follow that engine, the GX200, the sources point to one specific fan model as they actually call it the gold standard, for serious confined space work.
They do.
Why is the RamFan GE5022, that 21-inch fan, considered the benchmark for the whole industry?
The GE5022 hits that sweet spot for most industrial jobs. A 21-inch fan gives you just a massive amount of air movement.
The volume you need to clear a big tank or utility vault.
And clear it quickly. But because it's using that GX200, it's still, manageable. It can be serviced in the field. It's relatively easy to move around. It's the perfect balance.
So massive airflow, a reliable engine, and a footprint that actually works on a job site.
Right. It's the default choice for heavy industry, for emergency response.
Yeah.
Anywhere you need powerful ventilation, and you need it now.
But wait a second. Let's drill down on a variant I saw. It's really specific. The sources mentioned the RamFan GH5005BC.
Ah, yes.
Also built on that Honda GX200.
Yeah.
But it has this added feature, brake cooling. What is that? Are we talking about cooling the engine or something on the fan itself?
That's a great question, and it's a detail that really speaks to the level of safety engineering here.
Okay.
In these hazardous environments, when you kill the engine, you need that big fan blade, the impeller, to stop instantly.
You can't have it freewheeling.
Absolutely not. You can't risk it generating a spark from friction in an explosive atmosphere.
Yeah.
The BC stands for brake cooling, and it's for the internal brake that stops that fan.
I see. So if that brake overheats from being used over and over.
It could fail, and that would be a huge safety hazard. So that extra cooling makes sure that critical safety mechanism works every single time, even under the most brutal conditions.
That is an incredible level of detail. They're engineering for the most dangerous moments of the job, starting it and stopping it.
Precisely.
But that brings up a huge question.
Yeah.
What about jobs where any kind of combustion engine is just, it's forbidden, a hard regulatory fail?
And that happens all the time.
When you're dealing with, I don't know, super volatile liquids, or you're underground and can't have fuel, what then?
That's where the innovation really has to kick in. The engineering has to shift away from gas entirely.
To what?
To a completely different power source. That's where you find the RamFan WB5001LB, the water-powered ventilator.
Water power. Okay, that's genuinely fascinating. How did that even work? Does it just turn a little turbine inside?
That's exactly it. It's ingenious because it uses something that's already on most of these high-stakes job sites. Pressurized water. From a fire suppression line or a heavy-duty pump, you run that water through an internal turbine, and that spins the fan.
And the benefit is no spark.
Zero ignition source. It's what they call intrinsically safe. It's perfect for atmospheres that are just saturated with explosive vapors, where even a tiny electrical spark could be a disaster.
So for jobs like cleaning out a crude oil tank.
Or certain types of trench work, yeah. The WB5001LB is often the only way to do it and stay compliant. It's the only option.
Okay, so if you were looking at the whole lineup, we're seeing these extremes. You've got the benchmark GE5022. You've got this specialized water-powered unit. And then there's the whole question of size. The sources talk about models from like compact and precise all the way up to just sheer brute force.
They do. Let's start with the compact end. The smallest one we've highlighted is the RamFan GG5010.
Okay, what's that one for?
It's a 16-inch fan powered by the smaller Honda GX850 engine. It's all about tight spots.
Manholes, that kind of thing.
Exactly. Manholes, small vessel entries. It's for fire brigades or utility crews who need something nimble they can deploy really, really quickly. You trade some of the raw power for portability.
And then you have the complete opposite end of the spectrum.
The total opposite.
The beast. The unit you bring when you need to clear the air in a space the size of a gymnasium.
That would be the RamFan GK5000. We are talking about a massive 28-inch ventilator.
And the engine on that.
It's powered by the Honda GX630. That's a huge V-twin engine built for continuous high-load operation.
So this is for the biggest jobs. The biggest. Clearing mega volumes from huge storage tanks, industrial barges. This is the horsepower king, built to run for days on end without ever faltering.
Okay, so beyond just the size of the engine, what are the real technical advantages these units offer? What are the performance stats that make a buyer spend so much more on this kind of engineering?
It really comes down to solving the physics of moving air in really complex spaces. The two big metrics are faster air turnover and high static pressure.
Let's start with air turnover. How much faster are we talking, and what does that actually mean on the job?
Faster air turnover means you hit the required air changes per hour, the ACH that safety regs demand, much, much faster.
So if a rule says you have to replace the air in a space every 5 minutes before anyone goes in.
A faster fan just crushes that waiting time. You're saving precious labor hours, you're starting the job faster, and you're making the area safe faster. It's invaluable.
And the second point, high static pressure. That sounds technical. What does that mean in the field? This one is absolutely critical. Static pressure is the fan's ability to overcome resistance.
Okay, give me an example.
Think about it like this. You attach the fan to 100 feet of that flexible ducting, that long hose that has to snake down into a tank.
Right.
That ducting creates a ton of friction, a ton of resistance. We call it back pressure.
And a normal fan would just stall out.
It would lose all its power, but a high static pressure fan can just punch that air through all 100 feet around all the bends and still deliver its full power at the other end.
Wow. So that means you can do the job with fewer fans.
And less manpower. It makes the whole operation safer and way more cost-effective. One RamFan can do the work of 2 or 3 lesser units that would just fail under that kind of pressure.
So the engineering actually helps you stretch the budget.
Exactly. It's all about system efficiency. And that extends to maintenance, too. The sources say these are built with modular, field-serviceable parts.
Which means zero drama for the customer.
Right. You don't have time to ship a 28-inch fan across the country for a tune-up when you're in the middle of a critical shutdown.
This moves us perfectly into the last piece of this, which is the procurement angle. All this amazing engineering is, well, it's useless if a buyer can't get it quickly and efficiently.
And with the right support, the sources are clear. The supplier has to be a procurement force multiplier.
The supply chain is just as important as the horsepower.
It has to be. The supplier has to operate at an industrial scale.
Yeah.
A partner like PEEnergy.com isn't just, selling a product. They're providing critical logistical support.
So let's break down what that support looks like for a B2B buyer on a tight deadline. First, the obvious one, wholesale volume and bulk pricing.
Yep, they need to handle massive orders for entire fleets of equipment. But just as important is the logistics muscle. Meaning they can ship this stuff to remote sites, pipeline staging areas, coastal refineries, you name it. And they can do next-day rush orders when something critical fails mid-job.
And then there's the paperwork side, which sounds boring but is vital. Instant compliance documents.
Oh, that's huge. An OSHA inspector shows up. The safety manager needs to pull up certifications, manuals, MSDS sheets instantly.
If they can't, the job stops.
The whole job stops. A good supplier has all of that ready to go digitally on demand. So you sail through audits.
Plus, they have to work with how big companies actually buy things.
Yeah.
We're talking business-specific financing.
Precisely. You don't buy $1 million of gear on a credit card. You need purchase orders, net terms, custom billing. The supplier has to facilitate that relationship.
So it really seems like reliability isn't just about the equipment itself. It's about the entire supply chain backing it up.
It's risk mitigation from the factory all the way to the field. You're paying for priority support and proven logistics, which is why you just can't roll the dice on some gray market fan when lives are on the line.
As we wrap this up, the big takeaway seems clear. Industrial ventilation is not a one-size-fits-all thing. It's a science.
It is. It requires these tailor-made solutions for very specific hazards.
We saw that with the water-powered unit for explosive vapors, all the way to that 28-inch monster for just clearing huge volumes of air. Every decision is calculated. The size, the power source.
It's all based on the toxicity, the space, and the sheer volume of air that needs to be moved.
Right.
And that leads to a final thought for you to consider. The huge difference in engineering between that compact 16-inch fan and the 28-inch V-twin beast. It's a direct reflection of regulatory rules and worst-case scenario planning. These devices aren't engineered to a price point. They're engineered to save lives and prevent multi-million-dollar failures. Every single dimension, every cooling system, it's all a calculated decision. So what other essential unseen industrial tools out there are engineered with that same level of specificity, with a design so perfectly reflects the regulation, moving beyond just function into total safety assurance?
A profound thought to end on. Thank you for joining us for the deep dive, and we'll catch you next time.